Hi, my name is Stewart Lynch. Lately I've been working on converting one of my apps from UIKit over to SwiftUI. It's going well, but there's one framework that I use a lot that's not SwiftUI based, but rather UIKit. And that framework is Charts. It's a fabulous framework used by developers all over the world, and it's highly respected. With it, you can easily display your data in a number of different highly configurable chart types. I'm going to show you how to implement this in SwiftUI using the bar chart view as an example. And if I do it correctly, you should have a strategy for implementing the other types in your own projects. I'll need to use UIViewRepresentable to bring it into my project and be able to access the different format options and to implement the coordinator class so I can access the chart view delegate functions. If this interests you, then keep watching. You can integrate charts into your project using either CocoaPods or Carthage, but I'm simply going to copy over the framework directly from the downloaded repository. So let's get started. First, you'll need to download and unzip the code. I've already done that, and I have it here on my desktop. But first, let's create a new project in Xcode. I'm going to call mine Charts Bar Chart. And I'll make sure that the interface and lifecycle are both SwiftUI, and I'll save it to my desktop. Now I can open the Charts master folder that you downloaded from GitHub and copy the Charts project file into your project. You can see it now in the navigator, but we need to add it as a framework. So select your target, and then in the Frameworks, Libraries, and Embedded Content section, tap on the plus button and add the Charts framework. That's all there is to it. Now, to save us some time, I've also created a struct for our model called Transaction. And you can download this from the resources link in the description below. Just drag and drop that file into your project too, making sure that Copy Items if needed is selected, and that your target is selected as well. You'll see that it's a simple struct called transaction with three properties: year, month, and quantity, and a static property that returns an array of these transaction objects, one for each month of 2019 and 2020. So make sure you build your project to compile the framework and update to recommended settings if noted. We're going to be building a chart to represent this data, and we'll be able to switch between years and even drill down on an item. If we want to represent a chart view, and in particular a bar chart view in a SwiftUI project, we'll need to be able to bridge it using UIViewRepresentable. So create a new Swift file and call it Transaction Bar Chart View. Change the import to SwiftUI, and also import charts. Now create a struct called Transaction Bar Chart View and make it conform to UIViewRepresentable. Let Xcode fix and let the type alias be Bar Chart View. Save, and then let Xcode create the protocol stubs. With that done, you can now safely delete the type alias. In Make UI View, all we need to do right now is create an instance of the bar chart view and return it. When we create or refresh the bar chart, we'll need to specify what data needs to be plotted. And this is an array of bar chart data entry. So at the top of the struct, create a new property called entries. That's an array of bar chart data entry. In Update UI View, we need to do the work that will plot the bar chart, and this will require a dataset. And that dataset has one argument, the data, or in our case, the array of bar chart data entry. Once we have that, we can create the bar chart data from the dataset. and we can assign that to the data property of our bar chart view, which is just the UI view that we're representing. Now, transaction bar chart view is some view, so right here we can create a preview provider and provide it with some sample data so that we can see what our bar chart looks like. So at the bottom of this file, create a struct outside the transaction bar chart view and call it transaction bar chart view underscore previews that conforms to the preview provider. And right away the preview opens up, but there's nothing to display. So inside that struct, create a computed property called previews that is some view. And that some view is our transaction bar chart view that requires an entries argument, which is our array of bar chart data entry. So we're going to have to create that array from our transaction models sample data all transaction. So first we'll need to import charts. And next we'll create a static function called data entry for year that has two arguments, a year and an array of transactions, and then we'll return an array of bar chart data entry. Within the function body, we can filter the transactions based on the specified year that's been passed in. Now, a bar chart data entry for a simple bar chart requires an X and Y value as doubles, as these correspond to the values we need to plot. So our computed property can simply use the month for X and quantity for Y. And then what we can do then is return the mapping of the transaction month and quantity to create our array of bar chart data entry. Now back in our transaction bar chart view, we can update our preview provider to use that function to extract the entries for a specific year from all transactions. Now let me change the preview to an iPhone 12 and see what we have when I resume the preview. And there you have it. At least that's the easy part. We have plotted the bar chart, but the presentation leaves a lot to be desired. If you're familiar with charts, you'll know that it is highly configurable, and bar charts are one of the simplest of the charts. So what I want to do now is to take you through a process that I use in order to determine how I want my bar chart to appear. And because we have a preview provider here, we don't have to run this in our simulator. We can simply make changes to our view and just watch what happens and keep tweaking it until we get what we want. Now this is just a test, so let me change the year to 2020, and you can see the data is updated. Right now this change isn't going to be dynamic for us. If we want to use this in a real app, we're going to have to tell the bar chart what data to use, and we'll make changes to the year. And that'll come later. So right now, though, let's just go back to 2019 where we have a full set of data. Let's start formatting our bar chart. Notice that the label is just showing dataset, when in fact the label should probably read transaction. Well, in order to change that label, all I have to do is assign a string to the label property like this. Now, if you have stacked or grouped charts, each one will have a data set, and each data set can have its own specific label. And one more thing that you should add in the event that there is no data to display is the no data text property. And this gets assigned to the UI view, the bar chart view we're representing. For the data set, which is the bars itself, we want to do some formatting. So create a function called formatDataset with one parameter, a dataset of bar chart dataset. Now I want to take advantage of SwiftUI's live reloading. So as I make modifications to this function, I want to see it happening. So all I have to do now is call this function after the data has been assigned to the bar chart view, providing our dataset as the argument. Now, there are a ton of properties that you can assign to the dataset, and I encourage you to check through the documentation for charts. The bar chart dataset class can be found in the Sources, Data, Chart Dataset folder. But what I often like to do when I'm exploring a new library is more random and guesswork. For example, if I want to change the color of my dataset, I will just start with dataset period, and then color, and see if there is a colors property or something like it. And there is. There happens to be one that's an array of NSUI color. Well, I've discovered that NSUI color is just a type alias for UI color. Colors in the array are reused as soon as the number of entries in the dataset it represents is higher than the size of the colors array, meaning that it'll just cycle through. So if I want a single red color for my bars, all I need to do is add a .red, a single element in the array. And if I resume the preview, we see that now all our bars are red. If I wanted to alternate between red and blue, I can add a second color. I'm just going to go back to a single one though. Now, what about the values that are displayed? If I start to type value, I see that there is a number of different options. One of those is value colors. And this is another array of colors. So if I want to make the values red as well, I can do that in a similar fashion, a single element array. You can explore all sorts of options, but the one that I want to change is the format for these numbers. I know that they're whole numbers, but they need to be entered as doubles, so they're all showing up with a decimal value. I want to format that number then. Well, there is a value formatter property that is a custom formatter that is used instead of the auto formatter if it's set. In order to use this, we can use the default value formatter function, and it accepts an argument that's a number formatter. So let's create one, and I'll call it formatter, and I'll assign the number style type of .none, which is an integer representation, and that's what I want. This formatter then can be used in our default formatter. There are many other properties that you can explore, so this is just an introduction. Moving on, we see that there are two vertical axes on our graphs, one on the left and one on the right. I only want to have one on the left, so to remove the right one, we can use a property on the bar chart view itself, and that is the right axis enabled property that's a Boolean. And if we want to remove it, we can add that property to our update UI view and set it equal to false. And I want to keep all of these together, so I'm adding that before the format dataset function. All my format functions will be at the end. Now notice in our graph that the space between what we think is 0 to 20 is less than the space between 20 and 40. And that's because the y-axis format's not really starting at 0, it's starting somewhere below our minimum number, but not 0. I want that to be 0. And the other thing that you'll notice is that the markers on the left, and if your numbers are small, will show decimal values too. So we'll want to format those values just like we did for the data set. And this means that we'll need to create a new function that we'll call format left axis. And that axis is a y-axis as an argument. And then, of course, because we want to see live previews, let's call that after our format dataset and pass in our UIViews left axis as the argument. How about we also change the label text color to red to match the bars, so that it looks like the label property is a label text color. And though we won't see this in the preview because our numbers are so large, we do want to ensure that they'll always be displayed as an integer. And like the dataset, the left axis has a value formatter property too, but this time it's an axis value formatter. So we'll need to create a default one with our own formatter. So let's use the same as before and copy and paste it. And then the formatter becomes the argument for our default axis value formatter. And finally, to fix that minimum value, to set the left axis minimum to 0, we can use the left axis.axis minimum property. Well, while we're at the axes, let's look at how this x-axis is displayed. These numbers 0 through 12 represent the months. And there's an access property of our bar chart view that we can use to format that to display the actual month names instead. So let's create a function that's called format x-axis that will accept an x-axis as an argument. And then we can call that inner update view passing in that UIViews x-axis. As I said, we want to display those labels as strings instead of numbers. And this is really a property of our data. So let's return to our transaction model and create a static property for that. It'll be a static var of months that's going to be an array of string, and each item in the array will represent the 3-character representation of the month in English. So how can we use this? Well, it turns out that the x-axis has a value formatter that is also an axis value formatter. But I don't want to format these as numbers. We want this to be the corresponding month that we just set up in our transaction. And for this, we can use the index axis value formatter. All you need to do is pass in a string array with the same number of elements that we need. And in this case, it's 12. And we have that, our transactions.months. Let's also switch from the top to the bottom, and we can do this using the x-axis label position property, and I'll just choose .bottom. So it's looking better, but it only shows months every 2 months. And one thing that I've discovered to improve on that is to actually scale the x-axis so that it will force a scrolling to the right. Let me show you what I mean. We can set the zoom scale on bar chart view in the X scale position only. So back in the update UI view, we can add this code where we'll scale X to 1.5, keep the Y scale at 1, and leave the position the same. Now notice how I'm only seeing up to August, but all the months are being displayed. Enter preview mode, and notice that you can now swipe to the right to see the remaining months. There is an issue, however. This is a very powerful framework. If you double-click on a bar, the entire graph zooms in. Now, that might be nice for some apps, but not for this one. I want to disable that. Back in Update UI View, let's deny that with a UIView.scaleEnabled false. And this disables all user zoom action, but not our scaling. And finally, let's change our x-axis labeled text color to red to match the others. Now there's one more thing we want to do before we update our content view so we can switch between years, and that's the legend. And as with everything else, we can format it too. So let's create a function for that will have one parameter, and that's legend. And we can call that after our formatting of the x-axis. Let's speed this up a little now, as I hope you see that they have a couple of ways to find out the properties. You can guess, as I often do, or you can check the documentation. So I want to change the text color to red. I also want to change the alignment to horizontal right and vertical top. And I know that the maximum height is always greater than the largest quantity value. So let's draw the legend inside the graph rather than outside, and bring it down a little bit by setting a Y offset of 30. Okay, that's good for now. It's time to test. We'll have some problems, but I'll show you how to resolve them. If we're going to be changing years, we will need to have one more property that's a binding within our transaction bar chart view, and it will be an int representing our selected year. And to fix the preview provider, we can add a selected year property using the dot constant and using 2019. Now let's open Content View and add a new @state property for that selected year, and we'll set it initially at 2019. We'll also need to import charts, as we're going to have to create an array of bar chart entries. So we'll create another state property now for bar chart entries, and we'll just set it as an empty array. Now for the body of our view, we'll create a VStack that contains 3 views. First will be the text showing the selected year using string interpolation. So let's do that right now. And to remove the comma, we can replace it with an empty string. Let's make it a little bigger by setting the font to a title 2. Next, let's create a button with a label Change Years. And for the action, we'll use an if-else statement to alternate between 2019 and 2020 when tapped. And below that, we'll draw our graph. And for that, we'll use an instance of the transaction bar chart view that we just created. And we'll provide our entries and selected year. For entries, we can use that static function data entries for years, and it's asking for a year and transaction. Well, the year is our selected year, and the transactions are our all transactions, which is that other static property. And for the binding, that's going to change. That will be $selected year. And finally, let's set the frame to a height of, say, 500. Let's run this in the simulator. Initially, it looks good, but as soon as I scroll, I see 2 things are happening. First, the bar chart scale in width, and we also lose the coloring of our legend. It's even worse when we change years. It keeps scaling. So let's go back to our transaction bar chart view to find out why. Well, every time we scroll or change years, this update UI view gets called, and we see that it will continue to zoom with a scale x of 1.5. So we only want to scale the first time, and that's when the scale is a default of 1.0. So let's fix that. If I test now, I see that it fixes the scaling problem, but not the fact that the legend formatting is still getting ignored. Well, we can fix that with 1 line of code. At the very end of Update UI View, we can tell the view that something has changed and that this will force a refresh of all modifiers. So use Notify Dataset Changed on the UI view. This has our bar graph being presented nicely now. But notice that when we tap on a bar, the bar is highlighted and nothing else happens. I could turn this highlighting off, and it's the UI View's highlight per tap enabled property. But I want that because what I want to do is to perform some kind of action when we tap on it, like display more information on the screen. Well, like a table view or collection view in UIKit, a bar chart view has delegate functions as well. So we'll need to finish up this video by adding that functionality in. If you want to be able to call delegate functions from a UIViewRepresentable, you'll need to create a coordinator so that your representable view can be the delegate. I have a video on UIViewRepresentable and UIViewControllerRepresentable for integrating UIKit into SwiftUI, and I'll leave a link in the description below. Just below the Update UI View function, create a new class called Coordinator that conforms to NSObject and ChartViewDelegate protocol. Xcode prompts you with an error to create the protocol stubs, so let's do that and move that makeCoordinator function down below our class so we can see it. In the coordinator class, create a property called parent, which is of the same type as the parent class, which is the transaction bar chart view. Now this requires an initializer, so we can initialize the parent. And now in makeCoordinator, we can return the instance of this coordinator class where the parent is self. And finally, when we make our view, we can assign the delegate to the bar chart view to be the context coordinator. And in order to do this, then we want to create an instance of the bar chart view. So we'll call it bar chart. And we'll make sure that it's accessible from other parts in our code. And then within makeUIView, we can assign the context.coordinator as the bar chart delegate before we return it. With this in place, then we can utilize all of the chart view delegate functions in our coordinator. If I jump to the definition of the chart view delegate, I can see that the delegate functions are all here, and the one that I want is the chart value selected. Within the coordinator, then, let's create that delegate function. Now, as I was prepping for this video, I had a lot more fancy ideas, but we're running so long now that I'm just going to simply create a string based on the entry selected. So let's first create a new binding variable called binding, and it'll be selected item as a string. Now the chart data entry is the superclass for bar chart data entry, and we know that we have an X and a Y value where X is the month and Y is the quantity. So let me create a string like this, which can be assigned to our parent's selected item. The month will be an array value in the transaction.month string array corresponding to the entry.x position. And for the quantity, it's simply the entry's Y value. Then we can assign a string composing both of these items to the parent's selected item. And remember that the parent is the parent view, and it has that binding property named selected item. Now, since this is a binding, we can bind it to the state property in our content view. But before we do that, let's fix the preview by adding in a selected item with a constant of an empty string. Returning now to content view, I'll create a state property called selected item, and I'll give it an initial value of an empty string. I can fix the error in our transaction bar chart view as we need to add in a binding to the selected item. And then finally, we can display that string by adding in a new text view below our graph that will display this string. If I run this now, I can see that it's almost perfect, except that the quantity is showing with a decimal point. So let me just fix this now by returning quickly to the transaction bar chart view and returning the int value of the value of entry.y. One last test now. Everything is working as designed. Now, when I was initially planning this video, I started to go crazy, accessing more chart functions and properties like animations of the bar charts and other visual changes, but I've gone on far too long, so I'll leave that up to you to explore and experiment. If you like this video and want to see more on this framework, leave a comment below. I'd be happy to do another one on one of the other types of charts, like a stacked bar chart data entry or two datasets in a bar chart, or perhaps a line chart or pie chart. Let me know. I have lots of other videos available and in the queue as well, so please check out the rest of my channel. You can also visit my website to see the apps that I have available on the App Store, and visit my GitHub page to see what I have available as public repositories. If you like what you've seen, give it a thumbs up and subscribe to my channel. And ring the bell to get notified when I post new videos. I'm most active on Twitter, so please follow me there as well to find out what else I'm up to. Thanks for watching.